All right. So on our things to think about list, you have your mastering homework due Monday. We'll do a group quiz today, and we haven't had one in a long time, so we're going to do an individual quiz on Monday. Since you don't have any homework over the weekend, you can spend that time studying for the quiz. I mean, it's homework due Monday night. You could, if you're an overachiever, start it before then. I mean, obviously, I would have started early, but I don't assume anything about other people's time management skills. Just this week. Alright, so I want to do one more example problem that's not in your PowerPoints before we move forward. And then we'll do some more practice problems, followed by more practice problems. The next slide would be the one that has hydrogen and bromine reacting. But I'm going to do a practice problem in between. So we can practice setting up our ice chart, then sorting out what information goes into it. Alright, so let's say I have an initial concentration of 0.76 molar for my COCl2, and I want to know the equilibrium concentrations of the chlorine gas. First thing, did I give you a balanced chemical equation? Yes, good. So that's not the tricky part. What do I now need to set up to start to solve this problem? Ice chart, ice table, whatever you want to call it. Alright, so what do I put down under the COCl2 in my I? Yep. Good. What about these two products? They are zeros. We don't have any yet. Excellent. Now in my change row, how much change does the ClCO2 undergo? Yep, negative 1x. What about the carbon monoxide? Yep. What about the chlorine gas? Same thing, plus 1x. So we just need to add them together down the column. What piece of information have I not given you yet that we need in order to solve this? Right, I need to give you K. The K for this equation is equal to, let me find it. Alright, so now what do I need to put in my numerator of my fraction? X squared, right, because it's product. And then what do I put in my denominator? Yep. Alright, so now, is there any simple way to solve this? No, so what do we need to do? Make it into our quadratic formula stuff. Move it around. Alright, so let's see what we need to do first. Alright, so what's my first step? Right, multiply that up there. Alright, now mathematically what do? We distribute, right, distribute that 0.304. Let's see what that is. In order to use the quadratic formula equation, what do I have to do now? Make everything equal to 0. Alright, so now I have A and B and C. Just in case you've forgotten since the other day, right? Alright, that's our quadratic formula. We would plug that in, negative. Alright, do you need me to show every step, or can I skip ahead a few steps? Alright, let me just make sure I got the right thing. 0, 4 squared. Come on. Alright, so I get those as my two possible answers. Which one of these two is the correct one to choose? The positive one, right? Because what units would this be in? Molarity, right? So you can't have a negative molarity, so that looks good. So, to answer the question, what is the equilibrium concentration of the chlorine? It is that, right? 'Cause that's what X is. Okay. Question mark. You do not have to. It's easier for me if you make it obvious what you're, like on the test, it's going to be, there's going to be so much math everywhere that you're going to have to be very clear about what your final answer is. So, boxes or circles or something. So let me know that this is the number I decided on. Because you can see there's just numbers everywhere. Alright, let's do this one then. Alright, so now I have hydrogen gas and bromine gas reacting to make bromic acid. I know the equilibrium constant of this reaction is to be 2.18 times 10 to the 6th. I now have switched the problem up a little bit. What do I have in this reaction? Do I have reactants or products at the beginning? I have products at the beginning, and I am looking for what would be considered the reactants. We do it the exact same way. It's just the way I chose to write the equation, right? So it's saying, in this case, I have and I don't have any of these guys. Okay. So, what should I do about my hydrogen? It'll be plus X, right? Because I'm starting with this, and I don't have any of that, so I'm going to be adding X over here. What do I do about the bromine gas? Same thing. Okay. What do I do about this guy? Minus 2X. Okay, so let me add this up. Chris. Oh yeah, sorry. Good catch. Alright, so now we want to write the K equation, right? so what do I put in the numerator? Products or reactants? Yep, put the products. And does it need to get raised to an exponent? Yes, which exponent does it get? So either one of these x's get raised to an exponent. Yep. I certainly can. So what can I do now in this case to simplify it? Take the square root of everybody. Let's see what that is. 2.18. Okay. Again, do you need me to write out all the steps? Okay, I'll skip ahead a few steps then. Yeah. Because they're set equal to each other, if I take the square root of this side, I have to also take the square root of that side. Yeah. Anyone else skip that? I said I'd skip to the end. Yeah. Ask away. Because the way I wrote the equation, you cannot do it the other way because the K is defined for this reaction. We haven't gotten to how to manipulate K. So, like in 10 minutes, that would be okay. Because of the way of K is defined for H2Br2 making this. If I wrote the other direction, I would have to change the value of the big K.
I guess because how am I going to know that instead of writing the product, know that it's like I still have the product of the X, but there's still a number at the bottom, and there's left,
It's because, right, K is defined for this equation. Right, so ignoring all the math, K is for H2Br2 making this, which is equal to this value. I did this on purpose to make it a little confusing. Then in this case, I have all of this, and I'm looking for the reverse reaction. But still, products over reactants, defined by how I wrote the equation. Right, which I will have to give you the equation, and so you know which direction the K is evaluated for. In about 10 minutes, I'll show you how to do it in the opposite direction. We're not ready for that yet. Do you have a question, Justin? No, you can't do that. Because that X is involved in a subtraction, and so you can't just cancel an X, top and bottom. You have to factor it all out. Do you need to show all the intermediate steps? Okay. Alright, so if we get this, which concentrations do those refer to? Those two. How do I go about finding this guy then? Substitute in, right? So I plug in this number for X Plug it in, plug it in. That's right, just like the air freshener. What is that? So what does that tell you about how far this went to equilibrium? Like how much of this is made, right? Because if we look at this, so little of this was made that this value did not change. Right, comparatively, this is 0.2 and this is 0.0002. Factors smaller. So it did not change the concentration of this at all. Because I have so much of this, and my K indicates that there's a lot of product made, right, to the positive 6 is a gigantic fraction. Right? So it means that very little of the denominator got made. So that the value of this didn't change really at all using significant figures. Keep that in mind. Next chapter, that'll be crucial when we talk about acids and bases and how concentrations change when we do different things with them. Because technically it's an acid-base reaction. But alright, questions about that? Want to do more of those? Feeling good on that? Sure. Let's see. See if I can come up with one more real quick. Let's try. Alright, let's say we have this. Hydrogen gas and chlorine gas making hydrofluoric acid. I have a K of 81.9, and I have these initial concentrations, and I want to find the equilibrium concentrations of all of them. So, what do I put in here for H? 1. What do I put in for chlorine? Okay. What do I put in for the initial concentration of the HCl? Okay. How many X's here? Right, -1. What about here? Okay. 2. Since you start with all of them, you assume that the reactants are going to disappear and the products are going to appear. It's a relatively good assumption, unless they tell you otherwise. What was that? Oh, yep, sorry. I was thinking, I didn't want this one to be quadratic, so I chose bad numbers. I think there's any way I can fix it. I can't, unless I change it. Do you guys want to do quadratic or just a regular? Change this to a 1. On the test, you will by then know a shortcut that you won't have to do the quadratic every time. But we don't know the shortcut yet. Yeah, no, we don't know the shortcut yet. We will. Let me think. I'm going to say if you've read your textbook, you already know the shortcut. But, gauging from the audience, no one has read the textbooks and no one knows the shortcut. So, I know, what is this thing? This thing is like some books. I don't know if anyone has books anymore, but these are books. This is the one we're using here, and if you had read the chapter that we're doing, you would already know the shortcut. And you are more than welcome to use it if you know what it is. On the exam, if it comes up, I will have you set it up and not solve it. Right, so like it'll be something like this. If we got to the point of the quadratic, I'll be like, set it up to the point of where you could solve it. And then, because the issue is not going to be you plugging it into your calculator, although it is sometimes. It's more for me just getting to the point that you recognize how to set it up correctly. So it'll probably be in the multiple choice section, like which of the following is the correct quadratic equation for the above reaction. So you can set it up. Similar to what the homework does, yeah. I mean, the issue is, by the time we get to the second test, we will have so much material to cover that you're going to be doing like lots and lots and lots of ice charts. So I got to pick and choose. Because we're not ready. These are easy ice charts. So, Chris. You're over 3 chapters. Right now, we just finished the first of the 3 chapters. Yeah, just 2 more chapters. No big deal. There will have to be, because everything we've done so far has to be in molarity, we are going to move into a range where it has to be in moles. And so we'll have to know, I already know, you will have to know the difference of when to use which kind of concentration. It's cool, it's cool. Alright, yeah, 15. 15 is the complicated chapter. And then I forget what 16 is. 16 someone. Oh no, solubility. So everything you've forgotten about what dissolves, what's a solid, what's not a solid.
Oh, yeah.
Net ionic equations, when they do-si-do, and they swap partners, and they make a solid. It's all coming back. Alright, totally lost track of what I was doing. (81 square root 9). Okay. Alright, in that case, let's talk about the last thing in Chapter 14. Which, okay, this looks overwhelming. It's not really overwhelming. Look at one thing at a time. Where's my little thing? Alright, so manipulating equilibrium constants, or equilibrium expressions. Alright, so when you do your balanced chemical equation, you could, in theory, choose, right, this is currently 1, 3, 2, right? You could have chosen 2, 6, and then what would this be? 4, right? Hopefully. In your head, you should have been like 2 times 2. If I set up using this current one, right, products squared over reactants to the 1, reactants to the 3 equals this. If I chose a different set of correct constants, whereas 2, 6, and 4, right, 4, 2, and 6, is the same as this one if it was squared, right, 2 squared, right, when exponents get squared, they get added together. Sounds vaguely familiar. Yes. Yes. Right? So I had squared, this is the same thing as saying K1 squared. Now I've mathematically just plugged in K1, which is now that. So this leads us to a few rules that we can use to kind of manipulate K's, which comes back to that problem where it looked like we were putting random stuff on the wrong side of the fraction. There we go. So if you have a reaction just like we did where I just changed the stoichiometric coefficients, I just doubled them. I take whatever in this case I doubled it, so it became squared. I could have tripled it. It would have been cubed, right? So that's how the K's are related to each other. And the problem we just did, right, where I had 0 reactants but all products, I can do 1 over K if I want to know K, right? I had the one step where it's H2Br2 HBr, and the K for that was what, 2 times 10 to the 6, something like that. No, I had none of this, 2, something like that. Whatever it was. If I wanted to make myself feel more comfortable and have reactants and not products, I take that K and I go 1 over it. And now I can use it so that there's 0 products and all reactants. So if I reverse the direction in which I am looking at my balanced chemical equation, then I take 1 over it. And then maybe that makes you feel less about solving it. I don't have a strong feeling one way or the other, 0s or 0s. But and this will come important later. If you have several balanced reactions, each with its own equilibrium constant, they are multiplicative. So they multiply by each other to get the new K for the overall equation. It comes from the fact that, right, K is a forward and a reverse ratio, and so you can't just add them together. They're multiplicative. Why don't we look at a few examples where we put these brand new laws into action. So, maybe you remember, whenever you did delta H's, there were similar rules about delta H's, right? I would give you an equation that I wanted, and you would have all these baby equations that you would then either flip it, or multiply it, or something to get to the net equation you wanted. Same idea. You have a you have a goal equation you're getting to. You have to figure out how to move these equations. Sorry, my arrow moves. Let me go here. You have to figure out how to rearrange the equations that you're given to get to the one you want. Alright, so let's take a look at, this is our goal, like that's the equation that we want, and I'm given two equations to use to get to the one I want. I'll call them 1 and 2. Alright, so looking at equation 1, does it has water as a reactant. Do I want water as a reactant? I do. It has hydrogen gas as a product. Is that something that I want? Do I need to do anything to this equation as of right now? Doesn't look like. We'll leave it alone. Alright, equation 2. Does it have iron on the correct side of the arrow? It does not. So what do we need to do to this equation? Flip it over. If I flip it over, what do I do to the K value? 1 over. Negative would be if it was a delta H. But it's a K, so it's a 1 over. So I will rewrite it. Maybe that's what the arrows were for. Maybe that's what I was thinking. I was thinking smart when I was making these. Alright, so if I now look at my new equation, right, cross that one out because I've already used it. Do these two equations now, 1 and my new number 2, do they combine together to make the equation that I want? Okay, what would be something that appears as a intermediate, a product and a reactant? Okay. What is something that appears as a catalyst, as a reactant in the product? The order in which they appear. No. So like carbon monoxide goes in as a product, means I put it in there to begin with, and it comes out at the very end, unchanged. So it's a catalyst. Carbon monoxide, or carbon dioxide, shows up and then it immediately gets used. That would be an intermediate. Sure. Maybe I'll write it down. Alright, so it goes in as a reactant, comes out as a product, and nothing's happened to it. It's still just CO. For the intermediate, an intermediate is a product that then gets immediately used as a reactant. So you don't have any way of collecting it. There's no way to scoop it back out. A catalyst, it's one of the things you put in at the beginning. And it should be one of the things that pop out at the end. So it doesn't count. It's the exact same thing. Okay. So yes, then we multiply them together. Right, so we get K net. 2.4 maybe? Great. Say that again when you reverse it. Oh, those are all gases. Sorry, my G's are just sloppy looking. Those are G's. That must have been an F. That should have been an F. There we go. All kinds of crazy typos. My fault. Alright, how about we do one more of these? No, I'll save it. You guys can do your group quiz. I'll do more of these because they're not on the homework till Monday. Still unit list. So we'll finish chapter 14. Bring your chapter 15 notes. If you bring them Monday because we'll probably get those started.